to lesson 11 on rates of change. This is a really nice topic, and it's one that can be quite straightforward to win marks in an exam, so I hope that you enjoy it. There it is. It can include all of that stuff, but mainly we're going to be doing the connected rates of change in models, and it's very much to do with rates. So we've been looking at this version of the chain rule where we introduced a sort of a dummy variable u and we cancelled it out. We looked at, there being a connecting thing between y and x, and it was t or u or something like that. And this sentence here is really important. So the way that you do well in these questions is you just write down everything that you've got, anything that you can differentiate it. And I think it's a good idea to write down what you want as well. I sometimes start with that. Okay. The word rate is crucial here. There's going to be a lot of differentiating with respect to time. Okay, so the examples that you've got in your notes, I'd like you to follow along my working, write out the examples, and then you're going to try some questions. So we've got this first example, and I'm going to write down, I always start by writing down what I want. I want the rate of increase of area, so I want dA by dt. And what we've been given is that we've got a square, and we've got information about the size and information about the area, so I'm going to write a formula that connects the area to the length of the side. I'm going to differentiate it. So dA by dx is 2x. And I look at what I've got as well. I'm told that the length of the square is increasing at a particular rate, so I'm told dx by dt, so I write that down. And I hope you can see it's not complicated to connect those two things that I have to get what I want. I'm going to do dA by dx multiplied by dx by dt to get dA by dt. This line here in my working is crucial for getting marks. You have to write down how you're using the chain rule and not just jump straight into 2x times 1.5. So write down this line of working. Anyway, I've got dA by dt, it's 3x. I'm told a particular length of side, x is 10, and so I've got 30, and then thinking about the units, I'm doing area by time because it's the change in area with respect to time, so you can always think about it like a fraction. It's dA, area is centimetres squared, and time is seconds on the bottom there. Okay, there's your first example. There's your answer, 30 centimetres squared per second, or 30 centimetres squared second to the minus 1. Example 2, very similar, but we've got a cube instead. So I'm going to write down what I want, which is the rate of increase of the volume of the cube. So I want dV by dt this time. And I'm going to try and take those words that I've been given and turn them into information about maths. So I know that I'm interested in length of edge of cube, and I know that I'm interested in volume, so I'm going to try and write a formula that connects volume to the length of the edge. And then if I see it and I can differentiate it, I differentiate it. So I've got dV by dx there. I'm also told that dx by dt is 4.2. And do a quick scan as well to make sure that all your units are the same and that they're not being sneaky by doing some things in centimetres and some things in millimetres. They're not. They tend not to, but it's annoying when they do and you miss it. Anyway, dV by dt, I can connect with dV by dx, dx by dt. And it's a straightforward case of multiplying those two bits together. I get 12.6 x squared. I'm told a particular length of edge when x is equal to 50. Then I can put that into my equation and get dV by dt. Write it out. I think this line's important to write because you want to show that you've substituted that number in, just in case you've got something wrong. This could be worth something to you in terms of method marks. And again, it's volume over time, so millimetres cubed second to the minus 1, millimetres cubed per second. Okay. This example, water's running out of a conical funnel at this particular rate. The radius of the funnel is 10 centimeters, the height is 20 centimeters. This one is a lot more complicated than the other ones. You need to see this and pay close attention. Do pause, rewind if you need to. Okay, so first of all, I'm going to write down what I want. I want to know dH by dt, where h is the water level. Now, because it's talking about how fast that water level is dropping, then I don't need a negative because that's implied by the word dropping, but occasionally if it said if it had been changing, it would have been a negative number I'd been looking for. So be careful of that. I've got a cone. Now the radius and the height are linked. And we're told the radius is 10 and the height is 20, and they're always going to be proportional, and it's linear proportion. So I know that the radius is equal to half of the height. I'm not interested in the height. I'm not interested in the radius. I'm interested in the water level, and I'm interested in the volume. So I'm going to use that information I've been told to replace radius in the formula I have for the volume of a cone. You should know the volume of a cone is a third of the volume of the kind of equivalent cylinder. So pi r squared h. We're replacing that r squared with the formula that we have that connects r and h. So there we go. So the volume is equal to pi h cubed over 12. Right, now we've just got one variable there. That's much better. So we're going to have dv by dh is 3 pi over 12h squared, or pi over 4h squared. So we've taken the information that we had and we've worked out dv by dh. We're also told that dv by dt is equal to 5. And remember at the top I wrote that we want dh by dt. Well, that equals dv by dt times d, and I think I had a little moment here where I couldn't work out what I was doing, which is quite funny, times dh by dv, like we're cancelling out the dv's. But we don't have dh by dv, we've got dv by dh, so we need to divide, very similar to what we've done in previous chain rule questions. So, sorry, because it goes a little bit out of shot here, but we've got 5 divided by pi over 4h squared, and then we're told that h is equal to 10. We plug that into the formula that we've got for dh by dt, and we get 20 over 100. My 4 has just gone to the top of my fraction, so 20 over 100, pi on the bottom still, and apologies, we just lost it, but I think I shoved the notebook across. There we go, we've got 1 over 5 pi, thinking about the units, volume over time, sorry, not volume over time, like a distance over time, so 1 over 5 pi centimeters per second. Okay, right, last one. I didn't do a worked solution for this because there's a nice solution it's taken from the textbook, and it's just a case of, again, writing down what you know, differentiating what you can, think about what's a constant, like pi, and what's changing, like radius. In the previous question we had height changing and radius changing, and therefore you need to eliminate one or the other because you can't differentiate very easily, so you've got 2 things changing. And then one thing that's kind of fun about this is that we do a lot of, you cancel the drs and you cancel the dv's to get ds by dt, so it's like it's 3 pieces of information. I think that's kind of nice. But anyway, have a little read through that, make sure you're happy with that one. And then I'm going to leave you to do these practice questions, and we're going to come back in part 2 and we're going to go through the answers of those. Thank you.